My name is Barry Patterson. I'm a member of the IMechE. I have been so for about 45 years. I'm here at St Teresa's Roman Catholic Junior and Infant School in Merton, where we've installed some UVC air sanitisers to protect the children. And today we're doing some air sampling just to demonstrate how effective the air sanitisers are. I'm now just going to go to see a group of children and describe to them how the unit works and what the Petri dishes look like, because I brought some in with me that I've done at another location to show them what grows on the Petri dishes. It's a very visual thing. It's called an air sanitizer. And sanitisation means cleaning, disinfecting. And what it does is it takes air in, passes it through, inside some lights. You can see them lit up through that little window there, and then comes out the top. And that special light, it's called UVC, ultraviolet light. And ultraviolet light comes from the sun. There's three kinds of ultraviolet light. You've got ultraviolet A and B, and those are the ones that give you sunburn and you have to be careful in the summertime. But you can get UVC from a lamp, just like a fluorescent tube. You know what fluorescent tubes are like? Long, thin tubes. And that's what we've got in here. We've got two fluorescent tubes, but they're UVC. If I put this piece of paper there, you can see it's stuck because the air is rushing into all these little slots at the bottom. And then the air travels past the light, and that's where the disinfecting happens in a chamber inside there. And then it comes out the top, and you can see how the air is blowing out the top. And what happens inside here is that the UVC, how it works, it destroys the DNA. Have you heard of DNA? DNA is the really tiny building blocks of virtually every life form. There's two kinds of microorganism in the air, really. You've got bacteria, which you'll have heard of, and you've got viruses, which you've definitely heard of recently. Viruses are much smaller than bacteria. And viruses need something to live in and grow on. That's how when they get in our bodies, they start multiplying and causing havoc in our bodies. In the viruses, you can't kill a virus, but what you do is you deactivate it. So the UVC breaks the links in the DNA chains. This machine can process 250 cubic meters per hour. When you use mathematics and statistics to work out what the average airflow is coming in, after you've recycled this air 3 times, there'll be about 94% of the air in this room will have passed through here at least once. So that's how you work out how effective these machines are. Right, this is the other part of what we do to demonstrate that these machines are working. It's very hard to measure viruses in the air. You need very specialist equipment, and it takes a long time to do it. So what we do is we measure other nasties in the air, other pathogens in the air, which we can measure using a Petri dish. Now, I don't know if you've heard of a Petri dish, but these are just plastic dishes. They've got a gel in the bottom called agar, and that is a nutrient, that's food for the bugs. We put one of these in this machine here. This is called an air sampler, and it's got lots of little holes in the head. There's 400 tiny holes, and we put that on there like that, and then what we do is we switch it on. It draws air in at a metered rate. It's sampling the air at 100 litres per minute. So it runs for 10 minutes. 10 times 100 is 1,000, and 1,000 litres is a cubic metre. So there's a cubic metre of air being sampled onto that agar plate. Once it's finished, we take the plate out and then we incubate it. And we incubate it at about 35 to 38 degrees C for a couple of days. And that helps the bugs. They think, oh, plenty of food, plenty of warmth, I'll get going here, I'll start growing and growing and growing. And after a couple of days, you take it out the incubator and you can have a look at it. Those are all the nasties and bugs that are growing in the air, and there's moulds and yeasts and bacteria growing. If you count all the dots up, they're called colonies, because they're colonies of bacteria. That's the kind of result you get in a typical school classroom, or a hotel, or a pub, or your kitchen at home. We do it in a room before we switch these machines on. Then we put one of these machines in, switch it on, and leave it for say an hour or so. And that's typical of a test after this has been running for an hour. And again, we count the number of dots. So you'd get a 90% reduction in the what you call the burden, the bio burden in the room. And that's how we measure how effective these machines are.